All right, so this is our first sections of notes for our pre-lecture. So this is a review of engineering calculations. It comes from chapter 2 in your textbook. So while you may have seen many of these concepts in other courses, we're just going to take the time to review them so that it's going to help you later on in the course and just so you have them in your notes as we move forward. So what you'll notice here is in all of the notes that we're going to use throughout the semester, you're going to have content. So it has blanks in it that need to be filled in either by watching the pre-lecture or it might be in lecture depending on the given day. And then there's some room for some extra student notes. So sometimes I add additional things when I'm talking and we come up with things spur of the moment. And this is just a great place for you to be able to put notes in. So you have content on your left and a space for extra notes on the right should you choose to use that. So, the very first thing we're going to talk about real quick, just to make sure that everybody's on the same page with terminology, is units and dimensions. So, a measured or counted quantity is always going to have a numerical value, and that's your something like your 3.56. And then you're also going to need a unit. So that's whatever there are 3.56 of. So don't ever give me an answer that's just a number. I need to know what that number represents. This is going to be really important in class when we talk about flow versus flow rate and mass versus mass flow rate. They are different things. So, for example, mass has units in terms of things like grams, but mass flow has units of grams per second. Those are very different things from an engineering standpoint when you're designing. So that's really, really critical. That's why units are so important. So what we do is we call any property that can be measured or calculated by multiplying or dividing other dimensions, a dimension itself. So anything that can be measured or calculated. So that's important. And then we can measure things and then we can calculate things. So we can measure things like length, time, mass, and temperature. So those are things that we can measure in the world, right? We can measure length with a ruler, we can measure time with a stopwatch, mass with a balance, temperature with a thermometer. But we can also calculate parameters. So a really good example of this is velocity. Velocity is equal to a length divided by time. So two measurable quantities, right? And something that we calculate. We can have things like volume, which is length cubed. And we can also have density, which is mass divided by volume. So it's mass divided by length cubed. So just keep in mind that there are things that we can measure in the real world, and then there's things that we can calculate. Many times, this is really, really helpful when we're thinking about what should be the units of something. So if you're giving me a velocity, you should be giving me a unit of length per unit time. If you're giving me something only in terms of length, you have the wrong answer effectively, right? Because you're telling me a length instead of a velocity. So keep that in mind because if you know how to calculate these things, you should know how to find the units for these things. Other important things, your units are algebraic variables. So when they're added, subtracted, multiplied, or divided, you can change how those units work. So important to note here is that you can have two quantities added or subtracted only if the units are the same. It's not the same with multiplication or division. If you multiply or divide units, as we did up here in this calculated example, we create new units. But if we're adding or multiplying things, or I'm sorry, adding or subtracting, you have to have the same units. So as an example, if you have 3 centimeters And in order to subtract the number 1 from that and get 2 centimeters, you need 1 centimeter there as well, okay? So you can think of this in terms of something like 3x minus x equals 2x. If you subtract 1 meter from 3 centimeters, that's wrong, right? So if we say 3 centimeters minus 1 meter is 2 centimeters, that's going to be a huge failure, right? At some point in time. Let's refocus here. Here we go. So this is something that's going to fail in real life, right? Because you're not paying attention to units. So that's part of the reason it's so important. And then lastly, we can always combine those units, just like we said, by multiplication or division. So if we have something like 3 newtons times 4 meters, we can get 12 Newton meters, and that's now a new unit. We can also divide 5 kilometers by 2 hours and get 2.5 kilometers per hour. So that's units and dimensions. Really keep an eye on your units as we're going forward in class.